Good morning, everyone. My name is Catherine Hirsch, and I'm here today with Xavier Coulon. We're going to be doing one of our final sessions for the Neon webinar series in promotion of Eclipse Neon, the 11th annual release train. Today with Xavier, we will be talking about Docker tooling for Eclipse Neon. A bit of information about Xavier. He has been a Java developer for several years, and since he has joined Red Hat back in late 2011, and he's been working primarily on OpenShift, JAX, RS, and LiveLoad and Docker components of JBoss Developer, Studio, and Eclipse. Today's session will have a presentation as well as a demo component. We are happy to answer questions as well at the end of the webinar. So you can send your questions to the Google Hangout directly. You can also send them to us on Twitter using hashtag #EclipseNeon, or you can email us at marketing@eclipse.org. So without further ado, I'll pass it over to Xavier.
Okay, thank you, Catherine, and welcome everyone. So yeah, I'm going to talk about Docker tooling for developers. A quick intro about myself, but Catherine already presented me. So I'm a senior software engineer at Red Hat, working there for more than 4 years. And since I joined, I've been a member of the JBoss tools team, as Catherine said, working on many components. And I'm also a committer on the Docker tooling at Eclipse.org. So the agenda I propose for today is the following. I'll give you a quick introduction to Docker, so we all share the same concepts when we will go further down with the tooling and the demo. Then I will talk about the Docker tooling that we have at Eclipse, and I'll go to show you how it works with a quick demo, and we'll finish with a conclusion and plans for future releases. So let's talk about Docker itself. Docker is made of several components. When we talk about Docker, we have images, containers, daemons, clients, and registries. So let's have a look at this. Docker images are what's called the build components in Docker. It's like a set of read-only templates made of layers. So basically, you start with a base layer, which is more or less the flavor of Linux that you want to run. So it can be, for example, Fedora or CentOS, or even Red Hat Enterprise Linux. And this is your base image. And then using some Docker files, you are going to create new images on top of this one by adding in new layers. So these layers can be installing some packages like JDK if you want to run Java applications. And then you can add a new layer on top of it, which will be, for example, installing an application server like Wildfly. And then maybe another layer on top of it, which would be customizing Wildfly if you want to add some specific driver for a database, for example. And you finally finish with a last layer, which will be your application components like Java classes, HTML files, CSS, JavaScript files, etc., etc. All of these will make your images. Once you have your image, you want to run it. And so when you run an image, you get a container. So a container is a run component. As I said, it's based on images. And the interesting thing about these containers is that they are going to contain all your application and dependencies, all the stack you need to run your application. Containers have a life cycle. They can be started, stopped, paused, deleted, paused and unpaused, removed. And you can do other things like connecting with connecting to a container to see what's going on inside. And you can also link container to other containers. So they can, for example, you can have a container with your application connected to a container running a database, and your application can connect to this database. And one important thing with containers is that they are immutable, or more or less immutable, and disposable. So the idea is when you need a container, you just run it, and when you don't need it anymore, you just remove it. And that's what should be done with containers. Maybe you need to take care about things like your logs in your containers. So you probably, on production, you probably would have a strategy to keep your logs to send your logs to a log aggregator, for example, or save your data for a database, or maybe using some specific containers for this. But the idea is when you don't need a container, you just dispose it. Now, All these image and containers are managed by Docker daemons, which runs natively on Linux because you already have your Linux kernel when you are on a Linux host. But if you are on a Windows or Mac OS machine, like some developers, then this Docker daemon is going to run inside the virtual machine. So until recently, or even now, I think if you have Docker machine, for example, it will be a virtual machine like VirtualBox. But if you have access to Docker for Mac and Docker for Windows, you still have some a virtual machine, but it feels like closer to the host operating system. So you have this Docker host which runs natively or in a virtual machine, and with this daemon, which is shown with a yellow oval at the middle of this diagram. But if you want to run commands on this, send messages, send commands to this daemon, you need to use a client. So by default, you get this. You get a command line interface for Docker, which allows you to run some commands. But there are also way over clients, such as the Docker tooling for Eclipse, which uses underneath an open source library made by Spotify to send some commands to the daemon. So this daemon is going to manage to have its own cache of image and manage some containers. And as you can see on the right side of this diagram, you can also, this daemon can connect, for example, to Docker Hub to pull some images as well. Which brings me to the last part, which is Docker registries. Docker registries are the distribution components in Docker. You have public instances like Docker Hub, which is the most famous, which allows you to share, to pull and push images. Most of the images you want will be probably on Docker Hub, like Wildfly, Postquake, MySQL, and so on. But you can also have your private instances inside your company if you want to share images between environments without going on a public site. So what are the benefits of Docker? First, it's lightweight. Running containers is much less expensive than having to start a virtual machine for each container. Once you have your virtual machine, you can run tens and thousands and hundreds of containers inside this single virtual machine. It's fast. Starting a container is very fast. It's portable across environments. So once you have your image, you can run it on your local machine, and you can send it on a registry and share it and use it on your test platform and production platforms. As I said before, image will contain the whole stack for your application. So you will have your application code, the application server, the specific version of JDK you want to run, and the specific OS that you want to run, or more or less. There is sandboxing between containers, so containers can't talk to each other unless they have been linked together. And you don't have to care about installing software like you did before when you wanted to install some Postquake, for example, or MySQL, or even Wildfly. You just need to pull a container and you just get the code to run it. So now let's talk about the Docker tooling at Eclipse. So the Docker tooling at Eclipse is part of the Linux tools project, but despite its name, the Docker tooling works on macOS and Windows. This project, this component of this tooling was initially started by the team working on the Linux tools project, but this specific part of Linux tools project, Docker tooling, and we also have Vagrant tooling, work on Mac and Windows as well. So the idea of this tooling, the goal of this tooling is to make Docker accessible from Eclipse, working with existing Docker tools such as Docker Machine for now, and I hope we can have support for Docker Compose in the future, with a focus on developer experience, which means that we provide you with wizards, views, launchers, which should provide you with the main actions that you want to do as a developer. For example, using a Docker file to build an image, running a container, linking a container to another one, connecting into a container to issue some commands, looking at the logs, etc. We may not provide you with all single flags that you would have in command line, but I think we have the most interesting ones in the wizard already. And we also allow reuse by other plugins. So for example, Docker tooling is split into two bundles. You have a core bundle, which provides you with an API, and a UI bundle, which consumes this API. And as a matter of fact, as I said, in JBoss tools, we have tooling for OpenShift. So OpenShift is a platform as a service, OpenShift 3, which has been released a few months ago. Is heavily based on Docker and Kubernetes. And as we do OpenShift tooling at JBoss tools on Eclipse, we needed to be able to connect to Docker daemons, to see images, to build images, to push images to registries. And so the OpenShift tooling in JBoss tools uses this Docker tooling as well. So how do you set up your environment? Well, first, you need to install Docker for Mac, Windows, or Linux. Maybe using Docker Toolbox or Docker for Mac and Docker for Windows Beta. The tooling actually does not cover this part. You have to do it by yourself before being able to use it without tooling. Then you install the Eclipse Docker tooling. You have two choices for this. Actually three now, because you have the update site on the Linux tools project at Eclipse, but the Docker tooling is, I think it's also available now in the Eclipse main update site. So if you have Eclipse Neon, you can already install Docker tooling from Eclipse Neon. You can also get it from JBoss tools because, as I said, we have some tooling for OpenShift. And so we have our own target platform with all plugins, all dependencies that we need for to run plugins, including Docker tooling. So for those who didn't have the chance to use Docker in the past, Docker tooling was already available in the March release. And in the March release, we already had the following list of features. So we had a Docker Explorer view, which is a tree view, and also two other views called Docker images and Docker containers, which are list views. We had some features like searching, pulling, and pushing images on Docker Hub or on or from Docker Hub. You have a wizard to run images, and as I will show you later, you have this wizard, and when you run an image from this wizard, we create a launch configuration, which means that you can rerun the wizard with all settings that you've passed, saved and available for further run. And the same way, you can build images from a Docker file, and we save a launch configuration, so you can build and rebuild again your image, and we keep the settings, so you don't have to specify the settings again and again. You can manage containers like start, stop, pause, unpause, kill, remove, and even tag container, and we can display container logs. What we've done in Neon was the following things. So we now have a Docker file editor, which is an awesome thing because it's an external contribution. So actually some users came to us and said that they built a Docker file editor and they wanted to share the code with us. So we had an IP review and the code was approved. And so we now have support for Docker file in an editor, and this is a contribution. So this is awesome. We also have other features such as executing shell commands using the terminal view. So the terminal view is a bit like the console view, but more with support for SSH, for example. We have an improved support for connections, because in the past, for example, if you had some Docker machines, many Docker machine connection to Docker machines, and you stopped some Docker machines and restarted them, maybe the IP address of your Docker machines would have changed in the meantime, and then we would have issues with connections, and it was not really properly handled. Now it should be much better. We can handle lost connections or unavailable connections, unavailable target connections, and you can change your settings with a new wizard, and you can re-enable your connection once it's all good. We also allow you to push to registries with authentication, and we have many bug fixes thanks to the automatic error reporting infrastructure. So that's something in Eclipse, at Eclipse. This is the kind of thing, when you have an issue, you can see maybe sometimes a dialogue popping up at the bottom of your screen saying that something wrong happened and maybe you want to send a report. And actually, this is very helpful for us. So yeah, please, if you see something going wrong, click on the send button, send us a report, and we will take care of it. We have many tests using SWT bot tests and things like this to try to make sure things work fine, but sometimes we miss some issues, and this kind of reporting is very helpful for us. Okay, so now it's time to go to a demo. But before going to the demo, I'm going to explain what I'm going to do. So first, we are going to start with an existing JBoss Wildfly 10 image. And using a Docker file, we're going to make a new image out of it, which will be in my namespace, but that doesn't matter really. The idea is to use this Docker file and to add some Postgre Java driver, JDBC driver in Wildfly, because Wildfly does not come with all existing JDBC drivers. So this means a few things like adding a jar file, making some changes in XML files, etc. And then we will mount a volume so we can share some data between the virtual machine and my host, which is a Mac. And we will expose some ports for remote debugging, for example. Now, once we have this Wildfly Postgre dev image, we are going to run two containers. We will run a container named Wildfly, which will be linked to another container named Postgres, which will run Postgres image. So this is what's going to happen inside the Docker VM. But as I said, we are going to mount a volume, and this volume is going to be mounted to a directory on my host machine, and we are going to use JBoss Developer Studio to publish some application code on this deployment directory. And since this directory is mounted on the Wildfly container, the Wildfly application server running inside this container will be able to pick the changes and deploy our application. So that's one way to build and deploy application from Red Hat Developer Studio or from Eclipse, but using containers instead of having to install software on the machine. Okay, so let's go to the demo. So I'm here in Red Hat Developer Studio 10, and I have this Docker Explorer view here, which is empty for now. So what I'm going to do, I'm going to connect to open a new connection. So this wizard is able to detect existing connection settings, and it's been able to detect that I have Docker for Mac running on my machine, and it's available via a Unix socket. So I can test my connection, and my connection seems good, so I can click on finish, and I get my connection here. Otherwise, I could also, so I get this error message because I already have a connection named Bobby, but it doesn't matter. I can also search for existing Docker machines, and I can see that I have one Docker machine running at the moment. It's named default, and if I click on OK, I will retrieve all connection settings, including the IP address and port, and pass to certificates. And on the same way, I can click on test connection, and I could connect to this one. I'm not going to use this one for now. I just use this Mobi connection here. So let's have a look. We don't have any container, but we have a few images, one named Postgre and one named JBoss Wildfly, and I have a Fedora as well. So as I said, the first thing we are going to do is build our own image based on Wildfly. So I'm going to take this Docker file here, and as you can see, we start from an existing JBoss Wildfly image. I already have it pulled here, but if I didn't have it, running this image will pull it. Running this Docker file would pull the image in background. Actually, I forgot to show something. We can pull images. So we can pull images here from Docker Hub. And let's say I want to search for an image named JBoss Wildfly. If I click on search, I can see that there is one image matching this name. And if I click on the next button, we are going to connect to a specific endpoint on the Docker Hub to list existing tags. Actually, this is something you don't get from the command line interface. You probably have to go to Docker Hub to see what tags are available. This kind of thing we included in the wizard. And actually, we can see that I already pulled this image tagged 10.0.0.final. Okay, so let's cancel this. So let's go back to our Docker file. So we start from this one, and we are going to do a few things here, like adding this module.xml, adding this jar file, replacing standalone.xml file from Wildfly with this one. And what we changed in this file is here in the data source, we create a new data source, which is here. And as you can see, it's going to use some environment variables to establish a connection to the database. We'll see later how it works, but this is, there is something very important here, which is this, Postgres. This is the alias that we will use later, so we need to be careful about the syntax here. Now, let's go back to the Docker file again. The next thing we do is we mount a volume with this path, which is a path inside the container. And actually, it's the specific directory which Wildfly is going to monitor to manage deployments. And finally, we expose two ports, 8787 for remote debugging and 9990 for management. And as I want to enable remote debugging, I need to change the default command that will be run by Wildfly. Especially, I will add this --debug flag at the end. So now we can run this Docker file. So I can do run as Docker image build. And I'm going to select a connection, because what's happening here, we don't build image inside Red Hat on top, or inside the Eclipse Docker tooling. We send all these files here in this directory, Docker file, module, Postgres, standalone.xml. We send all these files to the selected Docker daemon. So it's going to be Moby here. And the Docker daemon is going to build the image. I'm going to give it a name, and it will be, as I explained before, Postgres dev. And I will keep the same tag because I know it's Wildfly 10 final. Okay, so let's build this image. This is pretty fast because actually there is no thing to download from the internet, no package, no dependency. Everything is local. It's been pushed to the Docker daemon, so it's pretty fast. And as you can see here, I now have my new image, which I just built. Okay, so we now have our Wildfly image ready to be run. So as I said, we want two containers. We want a container with Postgre and a container with Wildfly. So I'm going to start with Postgre. I'm going to run it. And actually, I already did this before. And since I did it before, I ran this container, this image before. So I got a container, but I also got a launch configuration. So all the settings that I had in the past, that I specified in the past, have been saved and restored in this wizard. So for example, the name for the container is still Postgres. There is nothing here very specific, but here I specified two environment variables, Postgres username and Postgres password with some values. And this is something specific to Postgre, to the Postgre image. When I specify these environment variables, at startup, Postgre is going to create a username and create a database for me so I can already use them. So let me click on finish, and we have this container starting, and as you can see, all the logs for this container are streamed into my Eclipse console. And now I have this Postgre container running here, and I have some ports that have been exposed, but we don't really need to care about this now. So the second thing is we are going to run the Wildfly container. So once again, I click on run. And now I'm going to specify all the settings that I want. So I'm going to give this container a name. Otherwise, Docker is will give it a name, but I want to specify my own name so I'm sure which one it is. I'm going to publish ports, and I'm going to keep the same ports, 8080, 8787, and 9990. I will explain this a bit later. I'm going to link this Wildfly container to the Postquake container, and this is here where I specify an existing container, Postgres, and I'm going to specify the alias. And this is where we need to be very careful, actually, because the Postgres, we need to use Postgres here because that's what I've shown you before in the standalone.xml file, where we need to be very careful about the syntax. So we have Postgres. And on the next page, I'm going to mount this directory to a deployment directory, which is somewhere here in code temp deployments. So when my container is run, it's going to, everything which is going to be published in this directory on my host will be visible, will be accessible from the container into this directory. Okay, let me click on finish. So Wildfly is starting. Okay, Wildfly has started. And I can see here that I have a link to another container, my Postgres container. I have some ports available and some volumes. And I can show in a web browser. And okay, I can access my Wildfly. So that's good. Okay, next, we are going to use a server adapter here. So I already created this server adapter. There are a few interesting things to note here. We have a server adapter for the Wildfly 10 runtime, but we checked this option here to say the server lifecycle is externally managed. So actually, this server adapter is not going to stop and start Wildfly, it's just going to connect to it. And here we specified, okay, I need to remove this one first. So we specified here a custom directory. You can only change it if you don't have any application deployed, which is why I just removed this one. We specified a directory, which is the one we mounted on the container just a few seconds ago. So things are linked together. When we are going to publish our application, it's going to be all the classes, HTML file, JavaScript, and so on, will be written in this directory, which will be available from the Wildfly container. So I can click on the Start button. Now, as I said, it's not going to start, but here it's just going to connect. I'm going to disable it for this. It's going to connect to the Wildfly container. And what I can do now, I can publish my application. And as you can see, my application is being deployed by the Wildfly container while it has been published on a directory on my host. So I can go here and show in with live reload server, for example. So I'm going to start my live reload server. And yeah, okay, I have my application. So I can do a few things like, since we have support for live reload server, even if my application is running inside a Docker container, I can come here to my application. I can see what, for example, my index.html page, which has been deployed. And I'm going to make some small change. Welcome to JBoss HTML5 at Eclipse webinar. Okay, I just saved. And if I come back here to Chrome, my page has been updated because we have support for live reload inside the container. So I made some change, I save. The server adapter publishes my change on my host machine. Wildfly container sees these changes, pick up the changes, and at the same time, Red Hat Developer Studio sends a message to this browser to say that something changed and we need to reload the page, and boom, everything is reloaded. Okay, I think it's pretty cool. Next, what we can see, so let's go back to the Docker Explorer view here. So we've seen a couple of things. We can also execute shell commands since the Docker tooling for Neon. So for example, I can use, since I'm connected to the Postgre container, I can do something like this. I have SQL command, and I can connect with this Postgre user, and I can issue some SQL statements like this one, select all from member HTML5 Mobi, which is, as you can see here, this is the name of the table that's being used. Where is it? Here. This is the name of the table that is used by my application. So if I do something like this, hopefully it doesn't work. Okay, let me just, I forgot the from. I'm going to copy this. Okay, I have, well, I don't have any data yet. So let me create some data. Let me put some data. I'm going to put my name, Coulon, and well, as you can guess, this is not my phone number. So let me register, and if I come back here and issue the same statement, yeah, I have some data now. Okay, cool. So yeah, just to prove that I can issue some commands in this container, and my Postgre container is actually connected to my application, and my application is writing some data in this Postgre container. Okay, so last thing I'm going to show you is remote debugging. As I explained before, we have this 8787 port, which is open, so we can connect to it with a remote debugger. So what I need to do is this kind of thing. I create a remote Java application launcher, which is going to connect using this project on my localhost 8787. So localhost is where Docker for Machine is going to expose its port. If you have Docker for Mac. If you have Docker for Machine, it's going to be some specific IP address. But Docker for Mac has its own proxy server, which is going to forward all incoming requests on localhost 8787 to a specific IP address. So let's click on debug. And my debugger, my launcher is already, my remote debugger is active. So I can browse here my endpoints. I can put a breakpoint here. When I want to list all members, I'm going to hit this breakpoint. And if I come back again to my application and click on refresh member, I hit my breakpoint, and I can see what's going on with my debugger. But keep in mind, I'm debugging some code that has been deployed in a Wildfly container. Okay, so we have a few other things that I did not mention before. We have this properties view here. So if you select a container, you can see, basically this is the kind of thing that you would get from command line when you do something like Docker inspect. You get, we have some info, like, well, actually all of this info, we can retrieve them for you. We have the same for images. And we can also do things like pushing. So let me just do this. We can push image to some registries. So for example, this is a registry that I created before for OpenShift. Otherwise, you can configure your registries here in Docker. You can manage registry accounts, and you can add some registries with some server username, email, and password if you need some credentials to be allowed to push images. And I think we are done for the demo now. So let me go back to the slides and let's go now to the conclusion. So a brief summary of what we've seen before during the demo. We can manage connection to Docker daemons. We can search and pull images. We can build custom images using Docker files. We can run image with specific ports, exposed ports, mounted volumes, and some links to other containers. We've seen before, the commands, but I didn't actually show them. We can manage containers. We can stop, start, stop, pause, unpause, and kill containers. We can use a server adapter, even if it's more part of JBoss tools, but we can use server adapters to connect to containers, and we can do some remote debugging on containers. So we've just released the tooling for Eclipse Neon. The next release of Eclipse will be Oxygen, and we have some ideas for Oxygen, or maybe before for Neon.1 or Neon.2, which will be this autumn or winter. We would like to have support for Docker Compose because this is something a lot of developers want to use. We have an idea of an image hierarchy view, so you can see how your image is built upon other images. Some user asked for support for Docker run commands. So instead of, for example, having to specify things in the wizard, maybe you could just get from an example somewhere on a blog post or somewhere else of a Docker run command, and you could put it in Eclipse somewhere in a wizard and get this command being parsed and have a launch configuration for it. Maybe in the JBoss Tools project, on top of Docker tooling, we would have a specific server adapter to make things even more integrated and simpler for the user, and improve registry accounts management. These are some of the ideas we have for now. Let's get in touch. If you're interested in Docker tooling, so as I said, there are many ways to download it. If you want more information, you can go to eclipse.org/linuxtools, which is the umbrella project for Docker tooling. There is a mailing list for Linux tools where you can get in touch with us, discuss about features or bugs or issues that you have. Talking about issues, you can also go to Eclipse Bugzilla under the Linux Tools product and fill issues on the Docker component if you have some issues or some ideas, some things that you would like to see. On the JBoss Tools side, we have a website, tools.jboss.org. We have a mailing list. We also have a Twitter account, an IRC channel on Freenode. And if you're interested in things around Docker and OpenShift, containers, I suggest you go to developers.rada.com, which is our main website, and you'll get tons of information, including what we call CDK, which stands for Container Developer Kit, where you will have a virtual machine running Red Hat Enterprise Linux with OpenShift, Kubernetes, and Docker if you want to play with it. And I think we have some time for question and answers if you have any. Otherwise, okay.
So I'll just I'll add a couple comments just to see while we wait if there are any questions that come in. So if you do have questions, please submit them to the Google Hangout now. We do have about 5 minutes left to answer questions, and while we wait for those questions to come in, I will add a couple of things just as a few reminders. The Eclipse Neon release went out yesterday at 10 a.m. Eastern Standard Time. You can head over to eclipse.org/neon to see what's new with Neon. In addition, we have one final webinar series for tomorrow. It's on automated error reporting, AERI, within Eclipse Neon. And all of our sessions, all of our webinar sessions will be available on YouTube upon completion of the series tomorrow. So if you did miss any, feel free to visit us on YouTube, on our YouTube channel under the playlist for Eclipse Neon webinar series, and you can get caught up. Other than that, I wanted to thank Xavier very much for his time and for the preparation that went into this webinar. Of course. And I don't see any questions that have come in. So we'll go ahead and conclude the session. If the questions do come in, if you have them after watching this video on YouTube, or something comes up, please send them to us either on YouTube as a comment. You can also reach out to us on Twitter using hashtag Eclipse Neon. You can email us at marketing@eclipse.org, and we'll make sure that your questions get answered by Xavier. All right. Well, thank you everyone for tuning in.
Okay, thank you very much.
Take care.